Okay, it's a pulverized coal boiler. This unit has 8 pulverizers. Each pulverizer will feed 4 burners across each deck. So there's 32 burners total. Like pulverizer A, there's 4 burners firing on this one. This is a B pulverizer will feed this deck. Right now we're just showing A and E pulverizers running. We have 4 burners per deck, running 8 burners total. Firing down low like this provides more pressure as you've got more water wall area to heat up. If you fire higher up, it'll push more heat up and give you better superheat temperatures. The next part of this, we have division walls or platens. These extract heat out of the flue gas stream. We have the finishing superheater. Up here the water walls come up, but the water wall tubes stack about 7 deep to allow space for the flue gas to go through. In here we have the primary superheater and the upper economizer on this side. And this whole section over here is the reheater. This is steam coming out of the HP turbine, which is reheated and sent to the IP turbine. All the walls here are made out of tubes. These are cooled by steam. These are the actual convection section here. The roof tubes are also steam on this. Down here we have the economizer ash hopper. All these soot blowers, when they blow, they knock ash down. You're blowing soot continuous. There is a lot of ash buildup. From here, it goes out to the lower economizer, then down to the air preheaters. Okay, here's some specifications to the boiler. It's 55 feet deep, 60 feet wide, 153 feet from the bowl nose down to the bottom, 188 feet to the roof tubes down to the bottom. It's capable of putting out 4.2 million pounds of steam an hour. It takes 150,000 gallons of water to fill it. Runs 2400 psig. The steam temperature is 1005 degrees Fahrenheit. The reheat's 1005 degrees Fahrenheit. Burns 350 tons of coal an hour. Put up 580 megawatts net. And it boils 8,400 gallons of water a minute. Down here we have the seal trough and the ash hopper. This is where all your slag will fall off, hit your slope walls, and end up down here in a hopper full of water. Your seal trough seals the boiler. This will expand about 11.5 inches from cold to hot. That way, with the seal trough, you can maintain your negative 0.5 inches of water column pressure in here. The whole boiler is suspended from beams across the top. That allows it to expand down. All your piping to this thing has bends in it to allow for expansion as this thing does grow. Okay, here's the water steam flow circuit of the boiler. You have the lower economizer, which is fed from the boiler feed pumps. Lower economizer, it comes to the upper economizer. From here, it goes up to the steam drum. All these lines here are outside the boiler. There's lines that come out of the boiler in quite a few different places. This comes out of the bowl nose, this line on both sides. Goes to the steam drum. Here it's mixed with the water that's went through the boiler pass. All the steam's been separated. They have a vortex breaker that is a screen up here. It goes down 18, 16-inch lines. That feeds your bottom water wall tubes. There's different places it feeds them from. The mixture comes up here, it's heated. It produces steam bubbles in the water, which makes it lighter than the water that's going to downcomer. That's what drives these boilers, is the difference in densities. 2400 psi is a really good pressure to run. As you get higher pressure, the steam gets more dense. And if you get high enough pressure, you'll lose your circulation. So 2400 is about optimum for circulation in this kind of a boiler without forced circulation. Up here we have cyclone separators, steam dryers. The steam is taken off and it's used to cool the roof tubes. These tubes here actually make the roof of the firebox. It also makes the walls of the two boxes back here. So all this stuff is made with tubes that are welded together, and they're using steam to cool these and water's cooling these. From here, the steam is collected from these box walls, goes up to the primary superheater. It's collected and then it runs back outside the boiler. We have sprays that cool the steam to 860 degrees Fahrenheit before it feeds the division walls. Division walls, these are 88 tubes wide, these panels. There's another set that's 44 wide in between them. These extract heat out of the flue gas. Up here, the steam is collected again, and their sprays control the outlet temperature. These are set for 1005. Those spray condensate from the feed pump, which cools the steam and goes through the set of finishing superheat tubes. Steam is collected here and sent to the HP turbine. Over here we have the reheater section. This is steam coming out of the HP turbine. It goes to reheater, and this goes to the IP. So basically the steam comes out of here, goes to your HP turbine. The exhaust steam comes back in here, it's reheated to 1005. This goes back to the IP turbine. Okay, this is the operational part of our pulverized coal-fired boiler. Down here you have your secondary air that comes in, wind box. Quite a bit of dust builds up because it's coming off the air preheaters, taking up dust. The air feeds up here to your burners. This is the secondary air coming in through your sleeve dampers. Then you have overfire air ports. These are used to control the NOx emissions. These burners are set for low NOx burners. They stage the combustion to lower the temperature so you don't get the high NOx formations. This just shows two burners running, A and E. You'll get ash buildup, slag buildup called eyebrows. There'll be a lot of slag buildup on the walls. We're using a water cannon setup. It's a jet of water, about 300 pounds, kind of like a fire hose that come out and hit sections of the wall where it's programmed for and try and knock the slag off. Most of this is radiant heat, this part of the boiler. It's very intense heat in here. These are the division walls or the platens. It's the third stage of the superheater. These get quite a bit of radiant heat. As long as you're finishing soup, it gets a little bit of radiant heat. So the radiant heat, these work better at low loads. The heat load stays fairly constant here. Higher loads, your back superheaters will work better. These require a lot of steam flow to keep them cool. There are certain loads in the boiler we really couldn't run at due to the steam flow versus the temperature in the firebox. All these tubes here are cooled by steam. You wouldn't think you could cool with steam, but the temperatures these things run at. Like I say, most of this is alloyed steel. 2¼ is about it for chrome content. High down here, it's probably a little lower chrome. Here's the bowl nose. This kind of keeps the fire from going over the top. It helps combustion. And here, when you're doing inspections once a shift, you look for little cones, or you can see any tube leaks will show up as a little cone of slag building up. You can see that. Up here, the slag buildup appears as white spots. The slag's pretty much white hot. Finishing superheaters, it will bridge across these and start plugging up the boiler pass. You have different soot blowers. These try and knock the slag off. The division walls come out quite a ways into the furnace. They're trying to pull quite a bit of the heat out of the furnace up here. All this here is your convection section. Some boilers will have 2 drums and tubes. This just has 1 steam drum. The water comes down here and is fed through all the water walls. There's water walls on the side too. It's a box with tubes that are welded together. So this is where all the boiling of the water takes place. Here goes your steam drum, have cyclone separators, dryer screens. The steam, your steam drum, it feeds like your roof tubes. And then these 2 box walls, these are cooled with steam. 4 sides, and the steam's collected, goes to your primary superheater, and then it's sprayed down to 860 to protect the tubes in your platens. From here it goes back up. There's sprays here that maintain the outlet temperature at 1005 degrees. Big thing is the soot blowers. There's a lot of little red dots with soot blowers. It goes in between the tubes. There'll be a little passage about 3 feet high for the soot blower and for maintenance work through these. Pretty tight area. There's a lot of tubes, a lot of bends. See, this is the reheater section. Steam comes out of the high pressure exhaust, goes back to the IP inlet. They have acoustic leak detectors that'll look for tube leaks. They measure high frequency noise, and they're fairly good at finding tube leaks, but they also pick up soot blower running. The big thing with operators to make sure the soot blowers are running. These lances will bend. They're going in about 30 feet or so. The high temperatures, it doesn't take long for them to start bending, especially without steam flow on them. So the big thing for plant operators to make sure you're not bridging across the finishing superheater. Division wells aren't building a lot of slag up. A real important problem is your primary superheater. This will start bridging over. Like I say, it depends on the coal, ash content, temperature, how much excess air you have. Once this plugs off, then all the flue gas goes over here and down and runs your reheat temperature really high. It's uncontrollable. This plant controls reheat using dampers down here. A set of dampers on this side and a set of dampers on this side. Tries to maintain 1005 here. This has sprays on it to control the temperature, so they'll set this for 1005 on reheat. Then the temperature here is they use sprays to control the temperature on your superheat. Down here we have the economizer ash hopper. As the soot blowers run, they'll knock ash down. Large chunks of, it's pretty friable material. Goes down to your economizer ash hopper. Down here you have your cinder grinders, grind up and transport the ash. This is coming out to the lower economizer, and then from here it goes out to the air preheaters. So the big thing is to monitor ash buildup and change soot blowing. If soot blowing is down for a couple hours, you'll definitely notice temperatures start to climb. The big thing, this whole boiler is supported from the top. It's all hung off of hangers. I can see the large beams. We mentioned that in one of the earlier videos. I can see down here, it grows about 11.5 inches. There's a water seal. Make sure this thing's full of water and it overflows into your ash hopper. This is all bottom ash hopper water. Your large pieces of slag will fall down here, hit the lower slope walls, and end up down here in the hopper, which is crushed up and removed. These are called the knees on the boiler. There's various names for it. But down here's, you can see the ash falling from up here 150 feet down. You can definitely hear when some of the bigger pieces fall, and it can cause some tube damage.